Okay, this is lesson 10.3. We're going to be talking about raising powers to powers, raising exponents to a power. Let's go ahead and go over the warm-ups. Pause the video. Start it back up when you're ready. Okay, 5 divided by 25 equals 1 over 5. X to the 8th power, because I would bring my 8 up and subtract it. Y would come down. It's negative, so it becomes positive, so the y becomes to the 15th power. If you have any questions on that, please come in and ask. You should have learned that. 55 over 25 is 11 over 5. This is going to give me x to the 11th power, y to the 14th power. When you move an exponent across the fraction bar, it becomes the opposite sign. So this is positive 2, down here it becomes negative 2. Positive 7, up here it becomes negative 7. We're not going to do number 3. Let's get right into the lesson. Okay. When you raise a power to a power, if you were in class, you would have heard me, Kevin, I'm getting ready to yell. You would have heard me say, pow, pow, multiply, because that's what we're going to do. Power to power, pow, pow, and I know you can't see it, I made an X with my arms, just like an X-Man. Pow, pow. Power to power, you multiply. So, why do you multiply? Well, we know the rule. You add exponents when you're multiplying like bases. X to the 6th power raised to the 3rd power. Exponents tell you how many times to multiply the base by itself. Well, when you have a power to a power, now this becomes your base. So I have x to the 6th times x to the 6th times x to the 6th. And we know that when you multiply variables with like bases, you add the exponents. Okay, so 6 plus 6 is 12, plus 6 is 18. This equals x to the 18th power. But instead of doing that, we can come up with a rule. The rule is, rather than writing it out every time, when you raise a power to a power, you multiply the exponents. Now let's look at that. That kind of makes sense. See, this parentheses right here, 3 times 2. The problem you run into here is you'll start multiplying exponents all the time. Can't do that. So 3 times 2 is 6. This is x to the 6th power. This is x to the 8th power. This is x to the 12th power. Uh-oh. What do we do with number 5? Well, I'm raising the 2 to a power and the 4 to a power, so I have to distribute the negative 7 times 2, negative 7 times 4. Now we're going to run into all kinds of problems. Watch this. Negative 7 times 2 is negative 14. Negative 4 times 7 is y to the negative 28. Is that my answer? Is that my answer? Of course not. Whenever you have negative exponents, you have to take the reciprocal. The reciprocal means you flip the fraction. For example, the reciprocal of 4 is 1 over 4. The reciprocal of 5/7 is 7/5. Okay? Oh, baby eraser. Baby eraser. Okay, so I have to take the reciprocal of this. Well, the reciprocal of x to the negative 14th, y to the negative 28th is 1 over x to the 14th, y to the 28th. All right, let's go to number 6. Number 6 is beautiful. You have to multiply all the exponents, even the ones you can't see. 4 is raised to a power. Okay, so that's your answer there. Oh, sorry, we've already moved on. You have to multiply the exponents, even the ones you can't see. Every number, every letter is raised to the first power. We just don't write it, so there's a 1 right here. So anytime I don't see exponents, there's a 1 right here. I like to write them in first. So now I have 4 to the 3rd power, x to the 18th power. 3 times 1, 3 times 6. Now, 4 to the 3rd power, I have to simplify. 4 times 4 is 16 times 4 is? Very good. Nobody knows it. 64 x to the 18th power. Okay. Let's move on to number 7. The 4 has to be multiplied to the 1, to the negative 2, to the 4. So this equals negative 2 raised to the 4th power. X raised to the negative 8th power. Y raised to the 16th power. Now, the negative in front of the base, in front of the 2, does not mean you take the reciprocal. I would not, nowhere in math is there the rule, negative 1, oh, to make negative 1 positive, you take the reciprocal. It means 1 over 1. No! So the 2 stays, the negative 2 stays negative 2, but it doesn't. I'll explain more later. However, I need to take the reciprocal of negative 8. Okay? So, again, this is just like negative 2 to the 4th power over 1. X to the negative 8th power over 1. Y to the 16th power over 1. These can be individual fractions that are being multiplied. Or they can be written like this. All over 1. And I can just move individual letters or numbers. So, this equals negative 2 to the 4th power, y to the 16th, over x to the 8th power. Now, negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2. So negative 2 times negative 2 is positive 4 times negative 2 equals negative 8 times negative 2 equals positive 16. So this negative 2 to the 4th power does become positive 16. Y to the 16th stays right there. X to the 8th stays right there. I'm done. Okay, again, I don't see an exponent. I'm going to put a 1 here. So I get 8 times 3, 8 times 1, x to the 24th power, y to the 8th power. Okay? Let's skip and go to number 10. There's a 1 here. There's a 1 here. Negative 3 has to be multiplied to all of my exponents. So I get 3 to the negative 3rd power, x to the negative 12th power, x to the negative 3 power, y to the negative 15 power. Now, I can't have that, so I have to flip everything. So, x to the negative 3 goes up top and becomes positive 3. Y to the 15th goes up top and becomes positive. 3 to the 3rd moves down. X to the 12th moves down. These negative exponents tell you to take the reciprocal. Now, 3 to the negative 3rd is really 3 times 3 is 9 times 3 is 27. So that's 27. I have 12 x's here, 3 x's here. Move the smaller to the bigger. Make it the opposite sign. It's positive 3, so now it becomes negative 3. So that gives me x to the 9th power. Y to the 15 stays up here. There's no other y's. Okay? All right, kids. That's it. Nice and easy. If you have any questions, please feel free to ask. Have a great day. Well.